I will use summation notation. So I'm going to move into this area. This is now getting us into chapter 3. So it's measures of center is, I think it's a weird word. It doesn't make any sense to most people. If you were to ask them, what's the measure of center? It means nothing to them. But it really says, what's the average? And we can't say what's the average because there are multiple ways of getting it, but it says, given that you have a data set, where would you expect to find the middle value? And if you were to add up these values, you would see that whatever tool you use should be somewhere in the center. So the mean is the one that we learned in maybe in 6th grade or 5th grade, where you would just simply add up your 3, 5, 8, 8, 9, 9. Right? We've learned that to be the average, but there is an arithmetic mean. There are other, and then there's the median, there's the mode. There are different ways of getting a so-called average. 1, 2, 3, 4, 5, 6. What is that? 8 and 8 is 16. 24. 33, 42, 42 over 6 equals 7. So 7 would be somewhere in the middle here of that data set. So that's the one that we learned, but there are other techniques. Now, instead of us kind of just talking about it from, the mechanics of it, for a brief few moments, I want to just talk about this sigma. It's an S, is what this is. But it's a Greek S. And so it's a way of using this very short, kind of a shorthand for telling you what to do. So sigma, if I put something like this in front of sigma, what he's really saying is that you're going to do a sum using whatever it is that's sitting in front. So sigma notation is a way of saying this is x plus x plus x plus x plus x. So sigma notation is a way of saying, I don't want to write this out forever. That's all it is. And so if I said sigma notation on 3, that means that it's going to be 3 plus 3 plus 3 plus 3. It's a sum of whatever it is that sits in front. It really doesn't matter what it is. If I say sigma over x plus I, it means it's going to be x plus I, x plus I, x plus I, and so forth. So that's the way to think about it, is that whatever you see in front of it, sigma notation is saying we're going to do a cookie cutter thing. Ka-chunk, 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 and we're going to do a sum of it.
Okay, sound effects.
Yes, special sound effects. You'll never forget it. The now there's another thing that you can do with it, we won't see in this class. Instead of an S, I want a big P. And so what's the Greek letter for P? It's pi. So if I did it with a P, or the Greek P, the pi, it means that we're going to take not the sum, but it's saying product, product, product. We're going to get the product of multiple values. No matter what that thing is that's sitting in front of it, we're going to just do the multiplication with that. So it's a common thing to see in mathematical circles and in writing. Now the thing is that how do you know when to stop? We have no idea when to stop. This just simply tells us what you're going to use. Ka-chunk, ka-chunk, ka-chunk. What's your cookie? What are you stamping out? So we have to tell it where to start. And I'll say from 1 to 3. So that means start counting using 1 as your first number, 2, and 3. So it tells you what number you start with and what number you finish with, so to speak. A better example of that, it's going to look like this. It tells you for I is some starting value to some ending value. Use them in your your counting. So let's say that we have 3 times I. What you do know right now, if you know nothing else, you know that he said ka-chunk, ka-chunk, ka-chunk. So I have to tell you where to start, maybe 2, and where to stop. And so this would be I is equal to 2. So you would do something like this, 3I is equal to 2, I is equal to 3, and I is equal to 4. And you go ahead and put those values in there, the 2, the 3, and the 4. And so it's the 6, the 9, and the 12, or the 20. 1 plus 6 is the 27. So I know right away, even if I don't understand this more confusing thing with the summation notation, I know that there is a ka-chunk, 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 ka-chunk. That's always going to be the case. And so you have to use these values to know when to start and when to stop. So it says start using 4 as your first for your first counter, 5, 6, 7, 8. So that's summation notation, and we will use it liberally, although it's often used without much of a discussion. But I think it's important to at least get a pretty good understanding of it, because you may see it in other contexts. The other thing is that if I want to know how many things there are, how many stamps we're going to have in there, you can't just simply say this minus that. You can't just simply say 8 minus 4, I'll have 4 stamps. It's actually going to be 8 minus 4 plus 1, because it includes the 4, the 5, 6, 7, 8. You'll end up with 5 different elements or terms. So it's really going to be the 8 minus the 4, right? Start minus the finish, plus 1 more, because you have to include the starting point. It's inclusive. So you always know how many elements there are. Start minus the finish, plus 1 more. So summation notation, I could say, all right, going from 1 to 3, 2I, we just know right away it's going to be these terms, and they're all going to be added together. But then it says start with 1, end with 3. So 1, 2, 3. So I don't have to do anything with the others. And so we go 2 times 1 plus 2 times 2 plus 2 times 3. We can come up with an answer there for summation notation. And then finally, let's say that I have something like this, 3I, and if I go from I equals 1 to 2, I know that, wait, how many terms will I have if I do this?
2.
Okay, good. So I tricked you into that one. Oh, no, I didn't. No, your 2 minus 1 is going to be 1 plus. So that's perfect, sorry. So if we work with the 2 that's there, I know right away it's ka-chunk, ka-chunk, ka-chunk. And I also know that it's going to be I is equal to 1, I is equal to 2, and we stop right there because this guy tells us where to stop. So thank you. Now, if we do that and look at the math here, plug in the I is equal to 1, plug in the I is equal to 2, and we get an answer. It looks like it's going to be 3 plus 6, or 9. So that one is just 3I, or it can be a value that's raised to a power. You just have to make sure you do the substitution. And finally, let's do this one last one here. And could I do this? I is equal to 0 and I is equal to 2. Now this one gets more interesting. It's 2 plus I raised to the ith power. So where do we start?
At 0?
Start at 0. And so tell me what to write then.
It'd be 2 plus 0 to the power of 0.
So 2 plus 0 to the power of 0. So that's perfect. That's I starts with 0. And you know there's going to be an I equals 1, I is equal to 2. And we're just going to do the ka-chunk, 0, 1, 2, 2 plus 1, 2 plus 2, and so forth. So that's straightforward, hopefully. So the one thing that I kind of lean on is just make sure you write this in some repeated way. Chink, ka-chunk, 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 and then just substitute the correct values of your start and stop to know when to finish. This would be, in this case, what is it? 2 to the 0 plus a 3 to the 1 plus a 4 to the 2. It looks like it's a 1 plus 3 plus 16. It should be a 20. There's another example that's here that you can see that's similar, where it goes from 0 to 2 again, 0, 1, and 2, and then just go ahead and plug in I where it needs to go. And where it gets a little bit weird is if it's this. I is equal to 1 to 2, and it doesn't matter what's there as the argument. It's always going to be sums of whatever that guy is, and you'll know where to start and where to stop. Those two aren't part of the mix, so it just becomes an equation where I is not a variable in the expression. So it just tells you how many of those threes to add up. And there's another example of this where it tells you we have a constant and there's no value of I, for example, that's in here as a variable. So that's summation notation. And I can then use summation notation to talk about how we come up with the mean for a value. And it's the standard mean for that you would have come across, like I said, in 6th grade. So if I want to get the mean of 35726, summation notation for the arithmetic mean says that I'm going to take whatever that value, whatever those values are in that data set, and put them into the summation notation formula. Now, a couple of things are going to be slightly different or strange to you because it gets a bit more formal, is that whenever I have a bunch of numbers, and let's say that they could be random numbers or just numbers in a set, we're going to use an uppercase X to indicate the family, the body, everybody that's in there. And we're going to use a lowercase x to indicate those individuals that are in. So x sub 1, x sub 2, x sub 3, x sub 4, and x sub 5. So we'll use a lowercase x to represent these elements. So when summation notation says get the sum over the subscript, it means that you're taking x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 and x sub 5.